Okay, so we're going to focus on arithmetic sequences, although when we do some practice we'll throw in a geometric sequence from time to time because they're fun to play around with. Write an equation that describes each sequence. Yeah, so when they say, well, we'll get to that in a second. Then find the indicated term. So what we need to understand when we see a sequence like this just written out is that there are n values already. The first number in the sequence has an n value of 1. Its position is 1 in the sequence. It's the first number in the sequence. The 8 is the second number in the sequence. The 11 is the third. And so those terms can go directly into the table. 5, 8, 11. You probably already see the pattern is increasing by 3. So we can just follow that pattern and fill these in. But then for writing the rule, make sure I read the directions. Write an equation. Okay, so an equation needs an equal sign. So the way we make well, let's just write the rule like we did before, and then I'll show you how to make an equation. If it's plus 3, plus 3, plus 3, it's an arithmetic sequence increasing by 3. Then the rule is going to have something to do with 3 multiplied by the n value. And when I say something to do with that, I mean we might have to increase this rule by some amount or decrease it by some amount to make it match the actual pattern. But we can test it and figure that out pretty easily, because when n equals 1, 3 times n would be 3 times 1, which would be 3. But I don't want 3 when n equals 1. I want 5. I want 2 more than 3. So I just add 2 to my rule, and I get the value that I expected. If I should try another value like 5. When n equals 1, 3n plus 2 would be 3 multiplied by 5 plus 2, or 15 plus 2 is 17. And so again, the term matches the position in the sequence using this rule. So that gives me confidence that this rule is correct. The way you make it an equation is you understand that the term t is based on the rule. So t equals 3n plus 2. And so I could find any value of t, like I could find this value of t using the rule. When n equals 7, I should get 23. Or you know what we could do? We could just substitute 23 for t and 7 for n, and make sure we get the reflexive property at the end. 23 equals 21 plus 2. 23 equals 23. So that's another confirmation that our rule or our equation is correct.